In the last video, I showed you the structure of water, so now let's take a look at nitrogen. Nitrogen, when you look at that, you think, oh, nitrogen, just a single nitrogen atom, but that's not the case. Nitrogen is an example of a diatomic molecule, which you read about. Diatomic molecules are two atoms of the same type bonded together, and there are several of these, and they exist in nature as diatoms. For example, when we find nitrogen in nature, it is strictly as N2, the diatomic molecule, instead of just elemental nitrogen. And so we have several of these. We have nitrogen, oxygen, chlorine, fluorine, iodine, hydrogen, and bromine. When you see those, know that they exist in nature as diatoms. So let's take a look at nitrogen. So I'm looking at my diatom for nitrogen. And so I know that my formula is going to be N2. The next thing I need to do is determine how many valence electrons I have. Nitrogen is in group 5. So when I'm looking at my periodic table, it's in group 15. And so when I look at my periodic table, I know that because it's in group 15, it's going to have 5 valence electrons. But I have 2, so I have 10 total valence electrons. Now when I have a diatom like this, I'm going to start out with 1, and I'm going to make it happy. In other words, I'm going to add 8 electrons to it. Then I'm going to add my second one, and I'm going to make it happy. So now when we look at these nitrogens, we see that they're both happy. This one has 8 electrons, this one has 8 electrons. Now I need to count my total electrons. And I like to put a little dot or a little check as I'm counting to see where I'm at, to make sure I don't miss any pairs or count any pairs twice. So I have 2, 4, 2, 4, 6, 8, 10, 12, 14. So in this example, I have 14 electrons, but I can only have 10. So when you draw your structure and make your atoms happy with 8 electrons, and you have too many electrons in your structure, then you need to add double bonds or triple bonds. So that's what I'm going to do here. I'm going to add a double bond. So I know that this isn't correct. So what I'm going to do is I'm going to move a pair from each side to one pair in the middle. So I'm essentially going to move this outside pair to the middle, but since they're going to be sharing it, it essentially just becomes one pair. So now my structure is going to look like this. Okay. I no longer have this pair and this pair because when I moved it to the middle, now they're sharing it. Okay. So now I'm going to count again. 2, 4, 6, 8, 10, 12. I'm showing now 12 electrons. Still too many. So I'm going to add another bond. So I'm going to take these 2, make them 1, and move them to the middle. So now my structure looks like this. And when I count this time, I'm going to see I have 2, 4, 6, 8, 10, which is what I need to have. So this right here is going to be my structure. Okay. Now, since I have a diatom, I only have 2 atoms. The only possible shape that I can have is linear. So anytime you only have 2 atoms in your molecule, then the shape has to be linear. So to clean this up, I'm going to use my bond notation here and use 3 lines to indicate that I have a triple bond. And then I'm going to come back and make sure that I put that lone pair on there. And so my shape then is linear. I don't have any other option. There's no other way for it to occur besides linear. Now if we look at the next one, we're going to kind of throw a curveball in here. So we've got carbonate. Now when we looked at naming last week, we looked at polyatomic ions, and this is where that periodic table I gave you is going to really come in handy, because it has the polyatomic ions on the back of it. So make sure you take a look at those. And when I look at that, I see that carbonate has a formula of CO3 2- or -2. So this is the structure that I'm going to have to draw at this point. Still start out the same way with getting my number of valence electrons. So carbon has 4, oxygen has 6, but I have 3 of those. So I add those together, I have 22. But what about this little charge that's right here? Since it is a negative charge, I know that it has gained electrons. And since it's a -2 charge, I know it has gained 2 electrons. So I'm going to add that to my total number and end up with 24 electrons. So just a little note, if you have a charge, so if you're dealing with one of these polyatomic ions, if it's a negative charge, you add. If it's a positive charge, you subtract, whatever the charge is. Okay, so I need to build a structure that has 24 electrons. Carbon is always going to be my central atom, so I'm going to start with carbon, and I'm going to make it happy. So I'm going to come in here and add my 4 pairs of electrons to make carbon happy. Okay, I'm going to put my oxygens on here, and it really doesn't matter where you put the oxygens since there's only 3 of them. I like to put mine in this arrangement here, kind of a T shape, but that's completely up to you. Okay, it really doesn't matter where you put those. So now I'm going to make my oxygens happy. So I'll come around and add 3 more pairs of electrons, okay, to each of my oxygens. And now when I look at those, I see everybody's happy. All of my oxygens have 8, my carbon has 8, so everybody's happy. So now I need to count how many I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pairs. 13 times 2, I have 26. But I only need 24. So like I told you in the example for nitrogen, if you have too many in your shape, you need to add a double bond. And so you look at that and you think, well, I don't know where to add the double bond. It doesn't matter. You can add it wherever you want to. It doesn't matter at all. So I'm going to add it right here. So I'm going to take this pair and this free pair up here, and I'm going to move those to make 1 pair right here. Okay, so my new structure looks like this. Now I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs. So now I have 24, which is what I need to get to. So I'm good. I have the right number of electrons. So now I just kind of need to clean this up a little bit and actually put it in my correct shape. So what I'm going to do is kind of look at how many electron domains I have and what type of shape I'm going to have here. So let me get a different color. So remember, I'm looking at electron domains just on my carbon atom here, because remember, I only look at electron domains on my central atom. Even if I have a double bond, that's still one electron domain. The electrons, even though there's 4 of them instead of 2, they're all in this same location. So this is one domain, this would be a second domain, this would be a third domain. So I have 3 electron domains, not 4, because the double bond counts as one domain. So I will go back to my table here, and I have 3 domains. Okay, so I'm going to be either trigonal, planar, or bent. But I see that I don't have any lone pairs. All of these are bonding pairs, so they're all bonding. So when I go back to my table, I see I'm going to have a trigonal planar structure with 120-degree angles. So when I draw this, it's going to look like this. Oops, let me put more of an angle there. So it's going to look something similar to this. Okay, they're not exactly 120 degrees, but you're getting them pretty spaced apart. I'm going to come back and look at where my electrons need to go. Notice I just kind of flip-flopped this structure. And it really doesn't matter how you do this. They just need to be pretty spaced, or spaced as evenly apart as you can get them. Now, let's take a closer look at this structure. Let me get a clean slide here. So, let me get a little bit closer look at my trigonal planar structure here. Now, first thing that I've got to do is I recognize that this is a polyatomic ion that has a 2- charge. So when we draw our structure for this, I have to do something a little bit different that I didn't do on my others. I put brackets around the entire structure, and I put that charge out beside them. Okay, so that's the first thing. Now, let's take a look here at this double bond. I just arbitrarily put the double bond there. It doesn't have to be there. It could have just as easily been here or here. So this is an example of resonance, okay? Because I could have had a structure that looked like this, okay, with my electron pairs, or I could have put the double bond at the top and had both of these down here to be single bonds. So it really doesn't matter. And so on your sheet, you'll check the little box here to indicate that yes, this one does exhibit resonance, because there are multiple shapes. So when you have a double bond like that, look and see, is there anywhere else it can go? And if so, then you know that that particular structure exhibits resonance. I hope this has helped you. If you have questions about any of the other structures, just shoot me an email or send me a text, and I will help you as I can.